Okay, my name is Jim Serafin. I'm the Complex Facility Manager at Oak Ridge National Laboratory. I work in the Facility and Operations Directorate. I am not a computer person, but all of my counterparts in the HPC area have worked with me and a team of engineers, mechanical, electrical engineers, to stand up a new class at the University of Tennessee, Knoxville, focused on data centers, data center management and technology. I want to thank you for this opportunity to be here. Great facilities. You all impressed me quite a bit. 5 years ago, I might have followed about 10% of everything that was presented today. Glad to say I'm up to about 20, so making progress. But in the last 5 to 8 years at Oak Ridge, we've more than doubled our data center space, and I've seen 70 MVA transformers installed. We've installed 6,000 to 8,000 tons of cooling since then. We've got a lot of big equipment being installed all around us, and it just seems like the sky is the limit for HPC when you hear the talks about exascale and their power and cooling demands. Mark Dean, let me back up a little bit. About the fall of 2014, a group of us were talking about, with some of our strategic partners, we were talking about the workforce and how we could better develop, through interns or through some means, develop the talent base needed to bridge the gap between computing and facilities. How do we get to those students that come out of school understanding both computing and the facility demands and some of the challenges we have with data center management and high-performance data centers. And I do work for UT-Battelle. We manage the lab for Oak Ridge National Lab. So we leveraged that relationship with UT to talk to Dean Davis about this issue. And within a few months, within 3 months, they had stood up a minor degree program in the College of Engineering and Computational Science. So Mark Dean called me one day and said, we've got the class structure all set. It's going to be 6 classes, 3 required classes, 3 electives. We've got one problem. We don't have the core class, the Introduction to Data Center Management and Technology. Do you have any ideas? So I thought about it a little bit, and I said, well, Mark, we have a lot of the expertise you need here at the lab, so why don't we explore the option of us teaching this class as guest lecturers, or through some means we could just travel down to the university and teach on a weekly basis. So the next thing I know, I have a group of my facilities folks and a group of my computing folks all in the same room together, and we're talking about this class. We're throwing ideas on the whiteboard. What do we want to say? What do we want to teach? We only have about 20, 25 classes to work with. And where we ended up was we found ourselves following the sequence of a traditional HPC project, starting with strategy and the different types of data centers that are available, different technologies, through the power and cooling design. Site selection is a big part of that, and then through operations, construction, all those elements, ending with DSIM and the actual management of the infrastructure in the data center. And within 6 months of Fridays, we met every Friday for 2 hours, developing curriculum, developing slides, critiquing slides. We actually had a class launched in the fall of 2015. We had, I believe, just under 20 students. Surprisingly to me, 16 of those students were computational science majors, only 4 engineers, 1 mechanical engineer. I hired one of the electrical engineers that graduated from that class, working for us today. We had another student present his final project. He did such a knockout job on his final project, he leveraged that into a job with Comcast, managing one of their data centers in Kentucky. So we saw some small successes with that class, enough to build upon and keep the class going. But I wish I had my lapel. Here's a breakdown of the class requirements. Basically, there's 6 required classes, 18 course hours required. The introduction to data center technology combined with a reliability class, and a maintainability class are the core curriculum, or their equivalent. There are equivalent classes also offered. But the best part about this curriculum is the emphasis on the internship program. Between ORNL and its strategic partners, we strongly encourage these students to come through our lab or other labs and participate in a data center management position in some capacity. And that's worked really well for us. We've always had anywhere from 6 to 8 summer interns roll through our area, but this past year we had a couple students out of this class, and the best takeaway I had is at the end of the summer we have final presentations, and the one electrical engineer said, you know, the best takeaway, my biggest lesson learned was when I make a decision, when I'm looking at a key decision on an electrical infrastructure element, I need to think of the data center as a system, not just the electrical infrastructure, because any decision I make here ripples through the control side, the mechanical side, ripples through the data center. It's not just about the electrical infrastructure. So this has been a lot of fun. It's great being able to share what we've learned over the last 8 to 10 years as practitioners with our students, teach them some of the best practices that we've learned. Our instructors are truly passionate about this. I tell the students on day one, this is a very unique opportunity. We're going to roll 13 or so instructors through here, take advantage of it, leverage them for all that they know, all they've learned, and we're often there for them beyond just this class. So we start to form good relationships with these students. But it is a unique opportunity. As Mark Dean would say, this class is offered to, I'm going to go back a slide. It's offered to more than just the C&S and the computer engineering students, and more than just the electrical engineering. It is open to industrial engineers and mechanical engineers. And he talks about expanding the breadth of knowledge of data center management. We really don't take a deep dive in any one topic area. We have a final design project that allows the students to explore the depth in any particular area of interest, but we're after broadening their perspective of data center management and how all the parts fit together. So you can see about half of the grade is associated with class assignments. So individual instructors will often give homework assignments. Half of your grade is associated with a class project. And probably the best learning opportunity for the students is this RFP that we issue. And we structure it like any RFP we would receive from DOE or other customers on the requirements to build a new data center. And the answer, we actually gave them a problem that we struggled with several years ago. It was a 12,000 square foot data center. We were consolidating a lot of our business IT enterprise systems into a secure area with UPS generator backup. We have in-row cooling in this area for research clusters. And it's a really cool design, but we gave them blank drawings, showed them where the chiller plant was, showed them where the power was coming from, gave them number of cabinets and size, and said, go figure it out. Design the network, design the location of the PDUs, CRUs, whatever you think is appropriate. And they really struggled with it, but that was probably the most valuable lesson that they got out of that class based on the feedback that we had. So that's about half of your grade. And then, of course, class attendance. Mark Dean will track class attendance as a small part of the grade. Now, this year we actually have 3 graduate students. So we decided to, in order to make this a graduate class for those students, they're taking on an additional project in the middle there. I show the 3 students in their projects. One is designing and modeling a fire suppression system for our data center. The other is developing a software environment proposal to support application management system allocation, et cetera. Another is developing a proof of concept visualization tool. I think that's to capture the metrics associated with all the monitoring done inside the box. So they're working on some cool projects with our folks at ORNL. So what makes this class unique for us is it truly does bridge our Computational Sciences Directorate and Facility and Operations Directorate. And to me, we may as well be one directorate, because one thing that's made us successful at Oak Ridge is that we try to over-communicate as facilities folks. We try to over-communicate with our customers in the computational area. That's why I'm the facility manager with the sole focus of computational facilities. It's a very robust, expensive infrastructure. It needs that type of focus. So we communicate with our customers at every opportunity. Our customers sit in on our maintenance review meetings, our outage planning meetings. They understand why it's better to have planned outages versus run to failure, why we need to take Titan down once a year so that we can get inside all the switchgear and look for loose connections. So we have a great customer. Already had a great starting relationship with them. But here's the team teaching the class. You can see it's about 50-50, 6 and 6 facilities versus computational. The curriculum flows kind of like this. I'll teach the first class what to expect from this course, why it's a great opportunity for them, introduce the class project. Stephen McNally, he'll talk about different strategies in data center design. He'll talk about different cost models, site selection, and get the students to think about beyond just Oak Ridge. Of course, there's Google, Amazon, different types of data center designs based on the need. We inject a small project management piece just to help the students recognize what PMBOK, that it exists, and B, why it isn't a bad thing to get your PMP after you graduate, so they're familiar with what that is. And it helps them, give them a little structure for their class project. Jim Rogers, he will come in and talk about some of the details related to hot, cold out containment, refresh of infrastructure, managing the day-to-day space on the floor. Nina Imam will come in and talk about efficiency metrics for data centers, including trapped and stranded capacity. David Grant, he's our mechanical engineer. He'll talk about energy efficiency, PUE, introduce PUE to the students, which is one of the requirements in our RFP, is to achieve a PUE of 1.3. Darren Norris, he's our computing facility engineer. He'll talk about the electrical monitoring system. We use an ION computer platform to monitor all of our energy data points. David will spend 3 classes going over different cooling design technologies and helping the students choose one for their project, one or several for their project. And then Rick Griffin, if for no other reason, I'm pleased that we're doing this class for Rick. He's within 5 years from retirement, and he is so passionate about electrical engineering. He could teach the whole semester. But the students get a great dose of power engineering requirements everywhere, from TVA, the 161 kV system, all the way onto the floor, onto the computer cabinet. 3 classes with Rick, and it's not enough, still not enough. Saeed Ghazawi, our industrial controls expert, he teaches the SCADA side of things and the different options for industrial control system solutions and why they're important to your data center. And related to that, there is a separate class offered on cybersecurity that most students would take as part of this minor, but it is an elective. Brett Ellis teaches the data center network design and the key attributes of understanding how to design a network for a data center, protocols, virtualization. Jim Rogers comes back and talks about, after the computer is installed, how to break the machine. So the LINPACK, other testing that's used to test against the benchmarks that were established for the machine during the commissioning phase. Bart Hammontree, our construction manager, he manages all the infrastructure improvement mods for these different HPC designs. He'll talk about the life cycle of the construction phase through the requirements definition from requirements through turnover to operations, because oftentimes we miss the importance of a successful turnover to operations, whether it's through the quality review process, O&M manuals, establishing the appropriate maintenance frequency, those types of things. Then I'll come in and I'll talk to the class about operational excellence. That's behind the curtain, people, processes, training, the things we do on a day-to-day basis that improve our reliability. I like to think we have a very high reliability culture. We don't have tier 3, 4 designs at our data centers, but we get a lot of reliability out of a tier 1, 2 system, and that's because of our people and processes. And Scott Milliken will come in, and Scott participated in development of an open source DSIM software that we use at the lab, so he's going to expose the students to that specific software and how they could apply it to their class project. And this year we have a couple new classes. One is software applications. Still don't have that spot filled, but we're making some traction with a few folks at the lab. And then Keith Gray of BP, he's going to fly to Knoxville and provide a class on lessons learned in his design, his experiences designing their large-scale data center at BP. We really appreciate that, Keith. Thank you. So 25 classes, as I said before, it covers a lot of ground. We don't take a deep dive in any one area, but we cover strategy through DSIM. So they get exposed to the different building blocks and how to thread through those to a final project, but I don't expect them to come away and be able to make a decision on size of cables under the floor, or whether to use raised floor or just slab on grade. We're not asking that of them. We just want, at a minimum, to expose them to the robustness of our infrastructure so that they can better participate in these discussions going forward. And for me, I think of total cost of ownership. So every decision that we make on the power needs for a future computing system has a ripple effect through operation and maintenance. So 5 years later, we're going to have to live with that decision and the associated operating costs. So if we estimate a 10 megawatt computer and we supply 10 megawatts and only use 3 to 4 megawatts, that's 6 or so megawatts of unused capacity, a lot of equipment we have to keep up with, regardless of whether it's being used or not. Rationale for this class, really our whole data center environment's getting more complicated. We've got, in the government world, we've got consolidation requirements. We've got sustainability goals, whether it's greenhouse gas emissions or PUE goals. 10 megawatts is not unheard of for a single computer, let alone the exascale estimates we talked about earlier. So we need to grow the expertise to deal with these problems tomorrow. And we really need outside the box thinking. We need to help, if it's computing folks, help them understand that it's not only important to keep the server up and running, but it's important to keep the facility equipment up and running outside of that cabinet. And scalability of our data center infrastructure. So designing our next data center with the subsequent computing requirements in mind. For example, we may not have our computing requirements fully understood on day one, so maybe we can design our power, space, and cooling platforms to be scalable for the lowest need system, and then as they add cabinets, we could add power, we can add cooling fairly cheaply. So how many of you landed in this industry by accident? And probably would have enjoyed taking a class such as this while you're in college. That's really why we're doing this. We're just, making a small step towards the end goal of growing the workforce. But we feel if we can, attract a few interns through this process to our data centers or our strategic partners' data centers, we're making a significant contribution. And one reason we were comfortable going to UT with this issue early on is we already had a relationship with their Reliability and Maintainability Center on the facility side. We always have had the last 3 years, we've had 2 or 3 of their interns help us get a predictive maintenance program off the ground, how to optimize our preventive maintenance work orders, all those facility side elements. But they really helped us get our foot in the door with the engineering group down at UT. We talked to the students about ORNL, why it's good to be located near them, why computing sciences is the hub of all the strategic initiatives at the lab. What is Battelle, UT Battelle? We explained that. We expose them to the executive order for the NSCI project and tell them that big things are happening there in Oak Ridge, being the host for DOE. With that, I think I have a few seconds for questions.